My name is Doug Wicks, and I'm a product manager for off-grid and battery-based products, and I'm located here in Burnaby, BC, Canada. So you may have attended some of the previous webinars that Roy Dingen put on. This is a bit of a follow-up to that, and we're going to go over some of the XW Plus installation information. There's quite a bit to cover. The idea here is to give you an overview of what's required for the installations and show you where you can get additional information. So we had maybe a problem with the microphone there. So just wanted to talk about safety for a minute. Always ensure that safe practices are enforced. This presentation is for information only. All installations should be installed and maintained by qualified personnel only. Read all the manuals and instructions before proceeding with work. Shut off, disconnect all sources of power before working on this equipment. Some of it is high voltage, and we need to be. Just another note, all the manuals have little warnings and notices in them. Please take note of those. So this is typical installation system design. And normally you would not have all of these communication devices installed. The center of the system is a Conext XW Plus, and you can see that we have either DC coupled components and or AC coupled components. We'll be talking about those. The XW Plus has two AC inputs, one AC output. And typically you would probably install a Conext COM box with the system. As an installer, you might use a Conext SCP, or you may use a configuration tool that's not shown in this diagram. A few things, kind of an overview of the things that need to be considered when you're doing an installation, and this is just kind of an overview for anybody that may be online that's not familiar with all of the parts of renewable energy system. One of the components is the electrical panel, and this particular electrical panel is used in Canada. It has a sub-panel already built into it with a bypass switch, and for this particular application, the original panel was removed and replaced with this. There's all kinds of wiring and conduit that needs to be installed, and always ensure that you meet electrical codes, permit requirements, etc. There's the installation of the PV panels, and here we have PV panels installed on a flat roof, and this particular installation is using ballast, so there was no penetrations in the roof membrane whatsoever. And these little blocks are basically cement blocks, and they provide weight to hold everything in place. There's actually a wind screen that's behind these as well to prevent wind from getting underneath them and lifting them up. There should be an equipment layout plan, and that plan should provide access, some air movement around the equipment. There fans in the XW Plus, so if we can keep the equipment away from living spaces, it'll keep that living space a little bit quieter. You'll see in this picture there's a back panel that's already installed on the wall. The XW Plus actually hangs on that. So this panel gets installed first, and then the XW gets basically hung right on there. And this is kind of what this particular configuration looked like when it was completed. Here's the XW Plus. They have a couple of charge controllers on each side. This assembly over here is for PV disconnects, and in this case they're using higher voltage PV. So these had to be rated for 600 volts. That's why they are as large as they are. There's also an installation power distribution panel that can be installed right underneath the XW Plus. This has got some AC breakers in it as well as a DC breaker, and it really simplifies installation for single unit installations like you see here. So this is that actual box, and it's called a mini PDP. The other main component of a renewable energy system is the battery selection. So a lot of folks nowadays are going to lithium-ion batteries, and here's sort of some comparison characteristics between the lead-acid batteries and lithium-ion batteries. Lithium-ion batteries have an energy density that's 2 or 3 times higher than lead-acid. So they're lighter and they hold a lot more energy. They can be charged more efficiently, up to 95%. They handle a lot more cycle charge-discharge cycles, and they have less emissions. Depending on what kind of lead-acid battery you're using, you can have water loss, etc. Whereas the lithium-ion batteries, they're basically emission-free. There's not a lot of maintenance required on a lithium-ion battery. It has a very high charging capability. And basically the trade-off is a low cost for lead-acid versus a higher cost for lithium-ion. But we all know that lithium-ion battery costing is coming down. So we're probably going to see more of these kinds of applications using lithium-ion. And the last part of the system is communications. So Schneider provides a COM box that's bought and installed as part of the system. It ties all of the components of the renewable energy system together and provides communication as well as an interface that you can look at, see what your production is. It will show you any errors. It's internet capable, so you can look at it remotely. And it connects to, as I mentioned, all of the Schneider equipment via ZAN bus, which is a modified CAN bus communication system. So let's talk about the XW product. This product has been around for quite a few years already. Last year it was kind of upgraded, and with the upgrade it provides higher power ratings. It can be installed in larger systems, and we can talk about multi-cluster systems a little bit later. We can provide off-grid AC coupling, improved battery management, and supports charging of lithium-ion battery packs. And it has a simple generator start-stop. That's for a 2-wire generator start-stop with an aux port, and a number of field serviceable components. Here is the sizes of the inverter depending on the location. UL is, of course, North America, and IEC is anywhere but North America. So the power ratings are higher for the non-North American version because of code requirements. The inverter is exactly the same. There is another inverter in the lineup. It's called the Conext XW. It's a smaller system. It doesn't provide all of the same features as the XW Plus, but for small applications it may be more. And I'm just putting it in here so that you know about it. Here's a comparison between the two. As you can see, the XW Plus is really not made for smaller applications, whereas the SW is the maximum size is 4 kilowatts. You can put 2 of them together for a total of an 8 kilowatt inverter supply. Now the XW Plus, it can be combined, stacked together, and in a 3-phase system you can get up to 102 kilowatts out of a system. And it'll also provide 3-phase versus single-phase. It has 2 AC inputs that we'll be talking about in a minute versus 1. It provides a number of different features which are very similar to the SW. It provides grid cell, whereas the SW does not. And the XW Plus is 48-volt batteries only. The SW can have 24 or 48, and so on. So for any 3-phase or grid cell or system above 4 kilowatt, we recommend that you use the XW Plus. Here's a few of the specifications for the XW Plus. And as you can see, it has a very, very high overloadability. This particular inverter is very robust and can be used for starting large loads. And it's a transformer-based inverter, which gives us this capability. So as you can see, you can overload it substantially for the time it takes to start a pump or a motor on an electric saw or some other device that has a current draw, and it'll handle it. This is a functional schematic for the XW Plus. There's 2 AC inputs and 1 AC output. So you'll see some more diagrams as we move on. And AC1 would normally be tied to grid, AC2 would normally be tied to a generator, and there's 1 AC out. Here's the power transformer that we were discussing a second ago. And of course this inverter is bidirectional, so it can supply power that is converted to AC, going out to a load, or it can take AC and charge the batteries either way. So there's a few basic operating modes to the inverter, and everything else that the inverter will do kind of hinges off of these 3 modes of operation. So there's a normal invert in charge, and in the charge mode, the grid is supplying power to the loads, and we're also charging the batteries. So in this case, the inverter looks a little bit like a load until the batteries are charged up, and we're also powering the loads. And once the batteries are powered up, we have enough reserve energy in case there's a grid failure. Pretty basic. If the grid becomes disconnected and our batteries are charged up, then the inverter basically provides power from the battery, inverts it into AC, and supports the loads. So now the inverter looks like it's a power source. In grid support mode, the inverter's injecting power onto the AC bus. What it does is it increases its AC voltage a little bit and adds to the voltage being supplied to the grid, by the grid. So this power can come from the battery. This power could also come from the PV bus. And you'll note here that we have a solar charge controller and an array, so this is actually a DC coupled arrangement, and we'll talk about that more later. Grid cell mode, we can sell power back to the grid for a FIT program, and so if the batteries are charged up and there's excess power, it can be supplied to the grid. It can also be supplied to the loads. So it's basically assisting in powering the loads or selling back to the grid. So with those modes of operations, there's some features that are also attached. So priority power is also known by different names in the industry. And what priority power does is prioritizes consumption of solar energy over purchasing utility power. So what that means, as long as you have PV production through a charge controller, that power is being used to support the loads. In this case, it's a little bit different than the previous slide, in that we're always maintaining a full battery charge, and the battery has priority. So if you're in an environment where you're going to have some grid outages, you want to keep the batteries charged up, that's what this priority power enhanced mode is all about. Now that's different than the previous unit in that what will happen here is the battery voltage will be used up to a preset level, and at that point, the inverter will start adding more AC power and keep this level of power that's coming in such that the batteries do not get discharged further. So now we're going to sell to the grid. So exports available DC power. So again, depending on all of the settings in the system, if the batteries are charged up, you can now set up the inverter to sell back to the grid. And of course, that's all subject to where you are located, what the utilities will allow you to do or not to do, and so on. So there are FIT programs. There are limitations of how much power you can sell. The XW Plus does allow you to make changes to all of those parameters, and you can set it up and hopefully recover some of your costs. In a generator support mode, now we have the generator that's bringing power into the system, and when you have PV production, you're now basically supporting the generator, or you can also, if the battery's already charged up, you have a large load set that's starting up, the generator may not be big enough to handle, then the PV system will actually support that equipment starting up. So we're getting into AC coupled power now, and AC coupled power allows a grid-tied energy export and AC coupled charging. So the XW Plus is a grid-forming inverter. So most of the time, those grid-tied inverters, they need to see a grid, and in this case, the XW Plus would provide that. The grid-tied inverter and the XW Plus are both connected to the same AC bus. So what happens here is, well, we'll talk about that in a minute as far as the AC coupling goes. And here we have AC coupled power with the generator. Now this is a little bit different. We can't actually have the generator connected at the same time that the AC coupled grid tie inverter is charging the system because any AC that might get fed back to the generator is a dangerous thing, so there needs to be a disconnect switch here that keeps the generator disconnected when there's PV production from the grid tie inverter. So these are, are a number of settings that need to be looked at when setting up the system, and we're not going to go through all of those. I will show you in the manuals later where you find these, but depending on the mode of operation that you're using and the features that you're using, these will need to be set up. If you can hold your questions till the end, that would be appreciated. So let's talk about the batteries and settings. So there's a number of settings that are associated with batteries. Battery cutout volts, high and low, that establishes battery operational limits. So this little chart on the side kind of talks about voltage settings. And we have a low voltage cutoff. If the inverter actually reaches that and there's no AC coming in, it will shut down. So we don't want that to happen. We have a place where we need to start charging batteries when we do have the capability to charge it, and the batteries will charge up to whatever is preset. And if there's too much charging, there's a high cutout, high level battery cutout, where the inverter will shut down. So recharge volts, that's the setting that initiates a charge cycle. I think that's pretty straightforward. You can do things like set a charge block timer, so that if you're wanting to if the batteries are run down and the charger is calling to charge the batteries, but you're in the middle of the day when electrical rates are the highest, you can block out that time, and it'll wait till that time has expired and then go about charging the batteries when utility rates are much lower. So this graph is a typical charging graph. And as you can see, we have a bulk stage followed by an absorption stage, followed by a float voltage. And there's a three-stage charge, which is the black line. There's the two-stage charge, which is the red line, where you don't actually go into float. It just goes back to possibly supplying power to loads. There's a little boost section that's shown here. That's normally used for flooded batteries, which are becoming more and more rare. We would not use a boost for VRLA or gel batteries. And then there's lithium ion versus lead acid. So there are definitely different characteristics between lead acid batteries and lithium ion batteries. And as you can see, there's a limited amount of use from lead acid batteries, and this may go down typically to 44 volts. So we have a voltage range of 50 from 44, so we can actually tell what the state of charge is very easily on a lead acid battery. But 44 is basically the cutoff where you still have a 25% state of charge left. With a lithium-ion battery, you can run it down quite a bit further, depending on the manufacturer, of course. And as you can see from this graph, this particular one, you can run it down to 10% state of charge. The interesting thing is about lithium-ion batteries is that the output voltage remains fairly flat. And that's why it takes a little bit different setup in order to monitor them accurately. So the other thing about lithium-ion batteries is they have a battery management system. And it's usually built into the battery pack. And today there's a number of different battery manufacturers coming out with lithium-ion battery packs. They monitor individual cell voltage. They monitor individual cell temperature. They look at balances between cells. They will basically prevent excessive charge or discharge by disconnecting the battery. And they may be autonomous or they may come with communication. So I just wanted to put a note here that the lithium-ion batteries, the BMS, does not communicate directly on the ZAN bus system. And because there's so many different types, we don't really have a standard yet that we apply. But we do have a lithium-ion application note that shows you how you can set up for a lithium-ion battery pack. And if it's something that we haven't seen before, we highly recommend that you contact us before purchasing or installing a lithium-ion battery pack, because we have done some testing on several different models here at the factory in Burnaby. So let's talk a bit about grid support voltage settings. So grid support voltage controls when the XW Plus is available to inject power onto the AC bus. So this basically is a battery voltage setting, and it limits how much battery capacity can be used for export or for running AC loads. So turning on grid support allows the XW to raise its output voltage equal to or above the grid voltage. So we're talking about AC here. So if the battery voltage is above the grid support voltage setting, it will basically supply AC power that can be sold if cell is also enabled. So there's actually two settings, grid support and cell. And a conventional grid support operation, what we have here is a PV modules and the solar charge controller. And as you can see, we're supplying power to the loads. And when the battery voltage approaches the grid support volts, the XW will gradually reduce the load support power. And it'll start picking up more from the grid. Now, to enhance grid support, again, we're taking care of the battery first. So the battery maintains a high state of charge, and any excess power is actually used to support the grid. Cell enable and cell block timer, we kind of touched on that before. So cell enable controls when the XW is available and limits the peak power available for export. And the cell block timer, if you want to not sell power to the grid and want to use more for self-consumption, you can set that block timer up to do that. Load shave enable and load shave timer controls maximum grid consumption from the grid and controls when the XW Plus will reduce consumption from the grid. So again, you can set that up so that when you have the highest cost of electricity during the day, that's when you're going to be able to do load shave. And you can set the load shave timer up to be more specific about the time of the day that you're doing load shaving. You can add a 2-hour delay before load shaving starts. If the battery is being charged and it's not been in float stage, that 2-hour delay will actually allow the battery to become fully charged before load shave action begins. And there's a few advanced features. Advanced features such as remote power off is something that's available to turn the inverter on and off using the aux port. There's a no load power save, so if you have absolutely no load on the inverter, this no load power save will bring the power consumption way down, even lower than the tear load setting. There's a 40-second cell delay, so that's an option. So when the inverter is going in and out of cell mode, you can set the delay for 40 seconds instead of the 20-second default. And that's there because if you have loads that are affecting the battery voltage, it provides a bit of hysteresis, and the inverter will wait for the battery to show, a consistent low voltage or a consistent time to support the grid for 40 seconds, and if it's there, then it will do that operation. So it's both in and out of grid cell. There's a generator support plus that allows the XW Plus to balance L1 and L2 loads for a genset. And there's battery energy balancing, which balances the battery state of charge in multiple battery banks. And all of those are advanced features, and all of those are available through the XW Plus with the right kind of configuration tools. So now we're going to talk a bit about AC coupling. So this shows AC coupling is done when we have a grid-tied inverter and it's tied to the output of the XW Plus. Grid on, grid tie, and energy export and local use, grid off, local energy use, and battery charging. So what happens here is this grid-tied inverter is controlled by the output of the XW Plus. So if the battery's fully charged and the loads are being powered and there's excess power, there is a chance that this will continue to overcharge the batteries. So the load, this inverter the output of it has to be curtailed. It has to be either slowed down or shut off altogether. And there's a number of schemes to do that. It can be disconnected, or there can be a load diversion where the power is directed to an additional load for perhaps like heating a driveway or using the heat some other way or just dumping it. And the third way, which is the best way, is a frequency shift. So the XW Plus does provide frequency shift power control. So as you can see, as the power changes, so does the frequency. And as the frequency changes, that controls the grid-tied inverters. And once it goes out of range, the grid-tied inverter will shut down. There's settings in the inverter for frequency shift power control. First first of all, you enable it, and then you go through and take a look at a number of these settings. And there's only one or two of these grid-tied inverters that will work with the Conext XW, and that's our own Schneider grid-tied inverters or SMA grid-tied inverters. Application settings. So priority power settings is solar priority power use. So these are the things that need to be adjusted when you're using priority power settings. Grid support is enabled, load shave is disabled, cell is disabled, and the grid support volts are set 5.5 volts below float voltage to keep the battery close to float. And typically we set the charge cycle at 2-stage instead of 3, because we don't want to have the batteries sitting there charging in float when we can actually start to use them to power the load that we have. Solar power priority use. So in this case, we have grid support enabled. We have load shave disabled. We're not actually pulling anything necessarily from the grid. We're not selling to the grid, and so again, we set our grid support volts, and we use everything we can from the solar panels and the charge controller to power the loads. And the same is true with enhanced solar power priority use. Only in this case, we're continually keeping this battery charged up. In parallel power, we're providing load shave enabled. We have set load shave time block. We have cell disabled. We're not selling to the grid yet. We have grid support enabled. We have a low battery cutout. We have the battery set on 2-stage cycling. So now we're able to use power from the grid as well as power from the batteries. And that'll happen depending on how we have our load shave time block set up, and etc. Cell mode. So now we're going to sell to the grid. So we have grid support enabled. We have cell enabled. Again, we're at charge cycle 2-stage because we want to move as much power through here. We don't want to delay because we're sitting in float. And we keep providing as much power and cell mode to the grid as we can. In an AC coupled mode, we have grid support enabled. We have all of the settings that we discussed earlier set up to control the grid-tied inverter, and cell is disabled. Generator support. So grid support is enabled. We have load shave disabled. We don't have a grid attached to it. Cell is disabled. Grid support volts is not used. We're going to use the low battery cutout, and the charge cycle is 2-stage. So now we have support for our gen set. So this is a matrix of the settings that are enabled and disabled. And depending on which mode you're using, what things are actually enabled and disabled. So priority power, we have grid support enabled, load shave disabled, etc. So it's a quick reference. So let's look at a few different solutions. Residential backup power. So here's what a diagram might look like. You have the grid coming into the main AC panel, and we're providing power to the inverter, as well as you would be providing power to a lot of the other heavy loads in the house that are beyond the capability of the inverter. The inverter is tied to a sub-panel, and the sub-panel is where your critical loads are. And we have, in this case, a generator that's ready to go, and we have a battery in the system. And normally we wouldn't have all of these things. We probably have the AGS, the automatic generator start, and we have a COM box, which is the most common communications device. And we may have a Conext battery monitor that provides more accuracy as far as battery management goes. So in this particular case, we have grid support disabled, we have cell disabled, we have load shave disabled, and we set our recharge voltage depending on the battery chemistry. The charge cycle's at 2-stage. We set a block start time for charging. We have a low battery cutout, and we have a high battery cutout. Let's talk about residential grid-tied solar with backup power. So now we have basically a grid-tied solar arrangement that's outside of the backup system. So it may be on its own FIT meter, and what happens is as long as there's a grid, this inverter's operating and you're getting some kind of money back for the power that's being supplied. The backup system is completely separate, so we still have the main panel. We have that meter coming back in from the grid to the main panel, and then it's the same setup as we previously discussed. This particular diagram does show the Conext XW or the XW Plus. They can both be used in this kind of configuration. And here again are all of the different settings, the functions that are enabled, and these are all basically associated with various settings that are found in the manuals. Here we have grid support disabled, cell disabled, load shave disabled. We're setting up the battery again. We're on 2-stage charge. We have our block times. It's pretty much exactly the same as the previous example. Residential self-consumption. So now we're tied to the grid. We have our main panel again. But in this case, we have the PV modules and a charger, and those are actually charging the battery, and that excess power is being supplied through the inverter to the loads that are hooked up to the sub-panel. So we're using all of the power that we can get from the charging system, the PV array, and the charger. If it's an IEC connection, there's a requirement to put a network safety switch in here, and we don't have to do that in North America, but it does have to be done in Europe, so we just show that for clarification. The self-consumption settings look like this. Now you have grid support enabled. You set your grid support voltage, cell is off, load shave is off, etc. And we have residential off-grid solar. So now we're completely off the grid. In this case, we have an AC coupled system that's connected to the XW Plus. Both the outputs of the inverter and the grid-tied inverter are tied to the AC bus in the sub-panel. Once the battery's charged up, the XW Plus is in charge of how much power is coming from the grid-tied inverter. And if the battery gets run down, then we have a generator that will start up and keep things going. And now we're off-grid, so we don't need any of the features that have to do with the grid. And then we still go through and set up how we're going to basically do our battery charging. So since there's no charge block start is 9 p.m., charge block stop is 6 p.m., so there's only a small window of time that we can charge the batteries. And again, all of these settings are adjustable. So we do have a few case studies. These systems have been used for banks and ATMs. The XW Plus is very robust, and we have have it installed in a number of countries where there's harsh environments. It does provide a lot of capability for starting large loads, and it's a very reliable unit. So as you can see here, this particular design has been used in over 300 ATMs in Pakistan. And if you look on the pictures on the right, you can see that's the XW Plus is right there. There's 2 charge controllers and a battery bank, so it's a pretty basic system. It can be used as for community electrification. So because these inverters can be set up in 3-phase configurations, and so you would have phase 1, phase 2, phase 3, and then they can be stacked, so you can get up to 102 kilowatt systems. In this case, they were using them as about an 86 kilowatt off-grid and backup system. And here's a few pictures on the side. You can see all of their charge controllers. Here's the XW Plus configuration. They have a whole power room set up. And that's one of the things about the XW Plus. It's probably been a little bit confusing because of all of the different modes and features that it has. But it's a very versatile unit and will fit a number of applications. And we have one example here of it being used in schools. So again, 300 schools and 20 health centers in rural Africa. And the size was from 5 to 20 kilowatts. And this is a set of charge controllers here, disconnects, and you can see a couple of the XW Pluses here. We also have worked with installers who are doing containerized systems. These can be of any size, 10, 20, 40 feet, different power levels. And here's a few examples. So again, 36 kilowatts, so you can see the inverters are stacked in here. They have pretty large battery banks, and there's a whole package sitting on a truck ready for delivery. And of course, telecom, where a lot of telecom towers run on diesel generators are consuming about 2,500 watts of power, and getting a PV system connected to them saves on diesel fuel, makes the whole system more reliable. And as you can see, these are packaged in an outdoor enclosure, and when they get packaged in an outdoor enclosure, you have to take care to ensure there's enough ventilation, especially for the batteries. The inverters will handle anywhere from minus 20, 25 degrees up to plus 60 degrees, but they do derate with temperature. There's a few specifications here, and you can find those in the back of the manual, and I'm just going to quickly show you where those are located in a second. And if you need any additional information, our website is www.sesolar.com, or of course you can email me, and it's douglas.wicks@schneiderelectric.com. And what I want to do now is just show you a couple of the manuals that are available. So there's 2 main manuals. One is this one, which is the installation guide. These are available on our website, and you don't have to sign in or anything. You can download these manuals. They're pretty good size. So the installation guide will take you through all of the things you need to do to install the units. Let's see if we can find some wall mounting pre-installation instructions here. So it gives you all of the dimensions for clearance, knockout selections. This picture actually shows the XW Plus with a DC distribution system attached to the side of it. And it shows you where the connections are on the bottom of the unit, etc. So I highly recommend that you browse through the manuals, and there's a lot of good information here about how to access them for wiring. There's additional information about some of the distribution, where the wiring gets installed, etc. Also, there's some information about ZANBus, which is a communication system between the devices. There's a picture here that shows you how it's all connected. So this is the ZANBus, which is serially linked like this. There's terminators at each end. There's some information in this manual about accessories. We mentioned the specifications. You'll find them in this section. And there are some wiring diagrams that are worth taking a look at. Here we go. So that's one of the manuals. The other manual that you want to take note of is actually the owner's guide. And the owner's guide actually shows, do this quick enough, here we go. It talks about monitoring operations, it talks about configurations. So using setup menus, charger settings menus, on basically all of the menus, how to get to them, how to set things up. There's a troubleshooting guide. There's the default section that tells you what the default the default settings are, and so on and so forth. In addition to that, we did talk about AC coupling. So there is an AC coupling guide that is also just freshly up to date on our website. You can take a look at that, and it talks about all of the requirements to set up AC coupling on the system. It gives you the AC coupled versus DC coupled, why you would do one and not the other. It tells you how to set up sizing for inverters. All of that information is actually here in this manual, and obviously we don't have enough time to cover all that detail in 1 hour. So that's also available. There's a lithium-ion app note, and if you're using lithium-ion batteries, there's quite a bit of information here about how you would connect those to the XW Plus. So you can take a scan through that as well. So good information. That's all published and sitting on our website. And the last document that I will tell you that's available is the multi-cluster planning guide. So if you're looking at a large installation where you're using, like you're going to actually power an island or some other application that takes a lot of power systems, this multi-cluster guide will take you through a lot of the requirements as far as setting up paralleled inverters, and I think we might have a drawing in the back here. Yeah, so it's probably not showing up too clearly here, but it gives you the full schematic drawing, multi-cluster, a multi-cluster system, multiple inverters. As you can see, there's sets of 3 for 3-phase. Each one has its own battery pack. There's a central Conext AC combiner box, all the charge controllers and inverters, etc. So again, I urge you to take a look at the documentation that's available on the website. And if you have any questions, you can email me, and either that or call us, and we will assist with some of these applications. Please do contact me if you have any questions at all. Again, it's douglas.wicks, W-I-C-K-S, Schneider-electric.com.